Okay guys, today we're going to continue our concept of using similar figures to help us today measure things that honestly we can't get practically the tools or to the point to measure certain distances or lengths. So if you'll make sure that you have this rough image sketched in your interactive notebook on page 15, or if you've run out of room you can go to page 17 and continue. So indirect measurement. If you look at this image here on the left, and it's on page 304 in your book, and I'll write that down. Excuse me. Let me just switch over here. So page 304. You can look there on page 304 and it'll help you a little bit. But indirect measurement, you see this person is 5 feet tall, and they cast a shadow that's 4 feet long. And what's really cool is the idea that maybe there's this, we've got the sun over here, there's our sun, we could say there's the sun, and it's casting shadows, and those shadows are going to cast, be at certain lengths proportional to the height of the object that's casting the shadow. What does that mean? Well, if you look at the ratio of, the height of the person 5 feet and compare it to the person's shadow of 4 feet, that should be proportional to the length of the tree, or the height of the tree that we don't know, compared to its shadow of 10 feet. Now, we could go about this a couple different ways, and we will. I'll show you one that we could see. First, we want to remember the idea of corresponding parts, or sides in this case. Corresponding sides. We should probably find those before we move forward anywhere. Well, if we look at these two objects, we've got the person, we've got the tree. Well, what corresponds in this image? Well, to me it seems like the height of the person, 5 feet, is going to correspond to the height of the tree that we don't know. Okay? And so we could actually make a ratio out of those two. Personally, by my choice, I like to, when I make these ratios, I'll try and put the unknown variable, or in this case the h, I'll put that ratio or that value in the ratio first. So I could write h over the height of the person, 5. So this is height of the tree compared to the height of the person. Okay? And if I make two ratios, then I automatically have a proportion, and that could help me find the missing value, in this case the height of the tree, which could be very helpful to know. You know, maybe this person, maybe they're not real brave, maybe they don't want to get to the top of the tree, but maybe even if they could get to the top of the tree, they would have no tape measure that could be long enough, or some digital way of finding an accurate measure from the top of the tree to the bottom. There's no way maybe to get that, practically speaking. So, hey, we're going to use this method. Okay, so we've compared the height of the tree to the height of the person first. We want to correspond in our proportion the same way. And so let's make another ratio. So since we used h first compared to the height of the person second, we're going to have the length of the tree shadow first, 10 feet, compared to the length of the shadow of the person, 4 feet. So again, just to recap as like yesterday, these are ratios of comparing essentially the tree to the person. That's what we're doing. All of our values are comparing tree to the person. So now that we've created these ratios and made a proportion, we can actually solve this proportion for the value of h and find the height of the tree. I'm thinking something right here. I hope that you see that there's a way we could simplify that, which would be a wise choice here. We could simplify this ratio, leaving h over 5. We could make this equal to 10 over 4. Okay? And we're going to simplify 10 over 4 by dividing by a common factor. In this case, I see 2. So 10 divided by 2 is 5, and 4 divided by 2 is 2. Okay, so this should make a fairly simple cross product scenario. Okay, because I don't know any way of getting from a 5 to get from a whole number factor to 2. Since I don't know that, I'm going to go ahead and do cross products. 2 times h, and make an equation, set this equal to 5 times 5, which is 25. And now we have a one-step equation, which is great, very simple to do. Divide both sides by our coefficient of 2. And we're going to have a height of this tree being 25 over 2, which I know that 2 can go into 25 12 times. And I'm going to have 1 over 2 left over. So 12.5 feet, because our units are in feet, right? And so we've determined that the height of the tree is 12.5 feet indirectly. Now we may be off a bit because think about some scenarios of how this could create some issues. The sun it's not moving, but the earth is. So maybe the shadows, maybe they'll change length just by a negligible amount as the earth rotates or something like that. But this is pretty close to be able to give us a value for the height of the tree. It's very reasonable. So now the person knows that this tree is about 12.5 feet tall. And maybe that could be helpful for lots of things, keeping the tree trimmed away from power lines, or you know, maybe they're going to shoot a squirrel out of the tree, something crazy like that, right? It could happen. So either way, that's how we use indirect measurement here. And now we're going to do one more example of using this proportional concept, but we're going to go to scale drawings. I'll probably pause the video here so we can talk through questions over indirect measurement, and then we'll continue. Okay, so here we are. We're going to talk about scale drawings now. Scale drawings, and we're going to write this definition down, are actually this idea where we can take a ratio of the distance in the drawing, meaning whatever our drawing is, whether it be a map or a painting, whatever it may be, and then relate that to what is true in actuality, in reality. What's the actual distance that's being represented in the drawing? Okay, so I'm going to put up a picture of the map here, and that we're going to talk about for the scale drawing, and try and relate this to us for just a moment here. Okay, so now you see we've got a picture of a map, and this may be more practical back when iPhones and digital devices were not as popular, but it's still very practical for understanding scale, because we know that when we look at a map, even on your phone, you're not looking at the actual size of a location unless maybe you're in Street View and you continue to zoom in as far as you can. But that's not really practical, especially if you're planning a road trip, because you wouldn't want to stay in Street View and trying to figure out from Ada, Oklahoma, how far maybe Atlanta, Georgia is, as you see in the map. You'd zoom out. And so as you zoomed out, you'd realize you're not looking at the actual size of the world or the United States from Ada to Atlanta. You're looking at a smaller version. And that's just practical, okay? So a lot of maps will give us a scale of how many inches we measure on the map that we're looking at to the actual distance that we're trying to figure out. So maybe in this map right here, if we measure 1 inch, we actually are measuring in reality a distance of 40 miles. Okay? And maybe this person in this map, we're looking at a map of a portion of Georgia, maybe they want to figure out, question, how far is Atlanta from Athens, or Atlanta to Athens, Georgia, home of the Bulldogs, UGA, right? So we want to figure that out. Well, it's great because we already have a ratio of, for every 1 inch we measure, we will get 40 miles of actual distance in this map. And so we could create a proportion and say, let's say the person measured on this map 1.5 inches. We could figure out, hey, the distance, how far is that from Atlanta to Athens? Well, I'm just going to stop the video here because I think at this point we know how we could find that distance. We could use cross products, and we'll talk that through during class. If you need help, please refer to your textbook. If you're watching this after hours, go to page 304. And again, we'll talk during class about how to do this. But good luck, and have fun doing your practice today.